Hey guys, welcome to today's lesson. Today we are now looking at the volume and surface area of spheres. Now, if you want me to demonstrate to you how the formulas are derived for the volume and the surface area of spheres, I'm sorry to burst a bubble. I'm not going to be going through it today. It is pretty complex, okay? You probably find some videos on YouTube about that, but certainly I know at the moment we don't really need to know that. We need to know what the formulas are and how to apply this formula. So first of all, the first formula you need to know, if you don't know it already, is 4/3 pi r cubed. That is for a sphere. 4/3 pi r cubed. Now, I remember that by thinking about the volume is always in cubics, and so it's just 4/3 pi r cubed. You've got to remember it. I'm sorry. The next thing is surface area of spheres. It's 4 pi r squared. 4 circles. Again, I'm not going to show you how that works. I don't think I could show you how that works, to be honest with you. But certainly you don't need to know that at the moment. You simply need to know that these are the two formulas for all of your questions. You learn them half the time they're given to you, but I still want for you guys as Year 10 accelerants or whoever's watching this video to try and learn these formulas. Now, that's pretty straightforward when you think about a sphere. Now, you think about a sphere, it's a circular kind of shape like the Earth. The couple of things you need to know, well, there's only one thing you need to know, isn't there? You simply need to know, what is my radius? For both those questions, I can find both out really fast. Harder questions, of course, they might give you the volume. You've got to work backwards to find the radius. We might look at one of those questions, or vice versa for surface area. Just with that, hopefully wrote those formulas down. If not, rewind it, write them down, have a crack at these two questions and see how you go. So, how did you go? Okay, so volume equals 4/3 pi r cubed. I always want you, please, to write it out with the radius substituted in. In this case, the radius is 5. Now, I'm going to deal with exact values because I can't be bothered calculating it, but you could do significant figures or you could do decimal places. It's up to you. But of course, in this instance, we can say 4/3 pi times 125. Volume equals 4 times 125. What's that going to be? 600, I'd say. 500. So we get 500 pi over 3. Okay. And we're going to say units cubed. Perfect. That's it. We simply apply it to the formula. We'll get our answer. Now, of course, that's my exact volume. You might do it to decimal rounding or significant figures. That's up to you. Okay, or up to what the question's asked. Surface area, again, just know the rule, 4 pi r squared, it's 4 circles. So 4 times pi times, in this case, it's 5 squared. Okay, so 4 times pi times 25. And of course, 25 times 4 is 100. So we get 100 pi. In this case, it's centimeters squared. So technically speaking, I should put centimeters in that first one. Centimeters cubed, because I was given the units, but otherwise, just put units. Answer the question. If you need to do decimal places or significant figures, up to you. Right, the next one. Now, not a great diagram, I'm afraid, but this is a hemisphere. Okay, it's half of a sphere. So volume should be no dramas because all you're really doing is you're halving your volume, right? So if I know that my volume is going to be 4/3 pi r cubed, I simply need to do half of that. So half of 4/3 times pi times 1 cubed. Okay, volume equals, well, a half times 4/3, just times the tops times the bottoms. That's 4/6 pi meters cubed. That's it, or volume equals 2 pi on 3 meters cubed. Done. Exact value, of course. Do decimal places, do significant figures, whatever you want to do. That's the process. Now, again, because when the volume's on the inside of it, if I'm just finding a hemisphere, we simply halve it. So the issue is going to come around when we have to do the surface area, because we know that when we cut something in half and we're doing surface area, we're creating another shape. In fact, we're creating a circle. So I can still say for my surface area, half of 4 pi r squared. Well, what's half of 4? 2, right? 2 pi r squared. But now I've got this extra circle on top, which is another pi r squared. So in fact, what we're actually doing is 3 pi r squared for a hemisphere. Not bad, yeah? So now in this question, I'm doing 3 times pi times 1 squared, because my radius is 1. Therefore, my answer is just 3 pi meters squared. It's kind of cool, right? But you got to remember that when you cut something in half, you're creating another surface. Unless, of course, that was like a bowl and there's no top parts. You got to read those questions. Well, the only other thing I'm going to show, I'm not actually going to do this question full on, but I'm going to say something like, if the volume of a sphere is 100 meters cubed, that's a big sphere, isn't it? Find the radius or find the diameter. So in this case, we're saying, well, we know the volume is 4/3 pi r cubed. You can do the same thing here for the surface area. We're just putting the volume as our answer. So 100 equals 4/3 pi r cubed. And realistically, this is not even a measurement question. This is going to be an algebra question. Okay, you could get rid of the times by 4/3 by dividing by 4/3. I'm going to do a little bit different. I'm going to times it by the 3 and make it 300 equals 4 pi r cubed, because I don't have a calculator, so I can't be bothered doing it. I'm going to now divide by the 4 to make it pi r cubed equals 300 over 4. I'm now going to divide it by the pi as well. You can do that in one hit as well, down there. And how to get rid of a cube? Well, hopefully you remember you're going to get a cubed root of 300 over 4 pi, and that's just going to be, in this case, meters as my radius. Now, of course, you would probably go and put that in your calculator and go and actually tabulate that to a decimal place or significant figures. If you want the diameter, of course, that's 2 lots of radiuses. You simply times it by 2. It's not that hard of a question. Same thing for your area of surface area. You do your 4 pi r squared and you let it equal the area, and you just go and find the answer for, by looking at equations. Gents, for me, I mean, it's not a really hard kind of topic. Simply for me, learn these 2 formulas, apply them, see how you go. Have a wonderful night.